Hi everyone, let's talk about today's LeetCode daily challenge. So today's problem, it says it's medium, but I think it's an easy problem. Yesterday problem I think was harder in terms of problem solving. Um, let's go and see what we have here. So you're given an array of strings of tokens that represents an arithmetic expression in a reverse Polish notation. So the whole point of this question is to understand what is this reverse Polish notation? What is that? Because that is not designed for humans. That has other purposes. Evaluate the expression. That's it, and return an integer that represents the value of the expression. There are some things that we should note here. The only operators we have are addition, subtraction, multiplication, and division. And each operand may be an integer or another expression, as we have in a normal expression. The division between two integers should truncate towards 0 to make the problem a little easier, not to deal with non-integer numbers. It is guaranteed that there will not be any division by 0. This is good. So that is a guarantee. And yeah, the input represents a valid arithmetic expression in a reverse Polish notation. This is also good that this is a valid expression. Otherwise, it would be challenging to figure out whether this is valid or not. Actually, not very challenging. So think about it, how we can figure out whether an expression is a valid reverse Polish notation or not. And at the end, again, we are guaranteed that the calculations, all of the additions, subtractions, multiplications, all of them will can be represented with a 32-bit integer. Let's take a look at the example to figure out what is this reverse Polish notation. You can read the Wikipedia, but as for this problem, it's not necessary. You can just take a look at the example and figure it out. So we have 2 plus 1 multiplied by 3. And the reverse Polish notation of this notation, this is sometimes called infix notation. Okay. So this is how we represent this expression: 2, 1 plus, and then 3, and then multiply. Okay, so let's go and see. I have a few notes about this reverse Polish notation. So the first thing is that there is no need for parentheses. This is not true for these kind of notations. This is sometimes called infix notation, if I'm right. Yeah. So this one is infix notation. And in an infix notation, you do need parentheses because of the precedence of the operators. But in reverse Polish notation, you don't need that because everything is clear. Okay, the execution order is clear. So operations are performed as soon as an operator is encountered. So let's have an example, actually. Let's have like this second example and see how we can evaluate that. Here, okay. And sorry, I keep going between the two. Okay. So the execution order is obvious. As soon as you see an operator, apply it to the preceding operands. And also, you can use a stack. It's going to be simple. Just have a stack, and you can do the evaluation. Let's work on this example and see what we have here. So we need a stack. Okay, all right. So this is our stack. So if you see a number, add it to the stack. If you see a number, add it to the stack. If you see a number, add it to the stack. If you see an operator, take the top 2 numbers in your stack and apply that operator to those 2 numbers. So in this case, 13 and 15 are going to be popped, and 13 by 5, which is 2, is going to be pushed onto the top of the stack. And later you see a plus, so you should pop the top 2 numbers, which is 2 and 4, and you should add 4 plus 2 to the stack. That's it. And at the end, you will have a stack that has only one number, just one number, and that is the result. That is the result. Okay, so let's go and see how we can write the code. We can have a stack and just do it. So we need a stack. So in Python, we can use a stack to simulate a stack. And then we need to iterate over all of the tokens one by one and decide if it's an operator, do something. If it's not an operator, do something else. So for token, what do we do? If is operator token, if it's an operator, take the top two numbers. So y, which is the top number, is going to become st.pop, and x is going to become st.top, which is the other number. And then I'm going to calculate the result. So result is going to be I'm going to define another function, evaluate x, y, and token. Okay, and then I'm going to add back this result to the stack. So st.push result, or append, I think, result. That's it. Else, we can just convert that token into integer and add it to the stack. So st.append int of token. And at the end here, we should return that one number that is in the stack. And we are done. We should implement this function, isToken. T, so return t equal plus or t equals minus. Okay, and then we need evaluate. Okay, okay, we need to copy this 4 times. Okay, if it's a minus, do this. If it's multiplication, do this. Otherwise, remember this one truncates towards 0. So we do integer, we do a division. So x by y, and then we truncate that, the result. Okay, that's it. This is evaluate, and we can just run this and submit. Great. So as a practice, think how we can recognize whether input is valid or not. So here in this problem, we were guaranteed that the input is valid here, but let's say we don't know that. How do you do that? Think about it. Where could this code go wrong if input is invalid? Please like and subscribe, and tell your friends if you like my explanations. And thank you.